Hello, science fans! Welcome to this deep dive into the often overlooked yet incredibly vital world of pumps. Today, we're diving into the world of pumps, exploring their diverse applications and the crucial role they play in our daily lives. Pumps are everywhere. They are truly ubiquitous. They are bringing water to our homes, ensuring we have access to clean and reliable water sources for drinking, cleaning, and sanitation. They are fueling our cars, enabling transportation and powering our modern lifestyles. And they are powering industries, driving manufacturing processes, and supporting countless essential operations. Choosing the right pump isn't just about moving liquid, it's a decision that has far-reaching consequences. It's about doing it safely, ensuring the well-being of personnel and the environment, efficiently, minimizing energy consumption and waste, and cost-effectively, optimizing resources and maximizing profitability. Imagine watering a plant with a fire hose. The force would be overwhelming and destructive. Or fighting a fire with a squirt gun. The effort would be futile and dangerous. Using the wrong pump can be just as disastrous, leading to inefficiencies and potential hazards. The wrong pump can cause breakdowns, halting operations, and leading to costly repairs. It can waste energy, driving up operational costs and increasing your carbon footprint. And it can even create dangerous situations, posing risks to personnel and the environment. Getting the selection right is a classic engineering challenge, demanding careful consideration and expertise. It's a challenge that blends physics, chemistry, and practical know-how, requiring a multidisciplinary approach. The perfect pump keeps systems running smoothly, ensuring consistent and reliable performance. It saves money, reducing energy consumption and maintenance costs, and lasts longer, providing a greater return on investment. In large operations, the right pump can save millions, optimizing efficiency and minimizing downtime. And it can protect public safety, ensuring the reliable operation of critical infrastructure like water treatment plants and emergency response systems. Throughout this guide, we'll break down the selection process, providing you with the knowledge and tools you need to make informed decisions. We'll guide you step by step, ensuring you understand each stage of the process. We'll simplify complex ideas, making them accessible and easy to understand, and show you how to match the pump to your needs, ensuring optimal performance and efficiency. Whether you're a student eager to learn, an engineer seeking to enhance your expertise, or just curious about the world around you, you'll see that pump selection is a fascinating scientific adventure, full of intriguing concepts and practical applications. Ready to see how science powers the world, one pump at a time? Let's get started. Let's embark on this journey together. Let's consider the science, the engineering, and the art of pump selection. First question, what are you pumping? The fluid's properties drive every decision. Is it water, molasses, wastewater, or acid? Each needs a different pump. Key properties: viscosity, thickness, temperature, corrosiveness, and abrasiveness. High viscosity fluids like honey need special pumps. Hot or cold fluids can damage materials. Corrosive or abrasive fluids require pumps made from resistant materials. Start by profiling your fluid. What is it? How thick? How hot or cold? Is it corrosive or gritty? For example, a water treatment plant uses different pumps for raw sewage and clean water. Getting this step right ensures a reliable system. Understand your fluid, and you're halfway there. Next, let's dive into the world of numbers, specifically as they relate to pumps. Understanding these figures is absolutely crucial for selecting the right pump for your needs. We're talking about flow rate and head. These are the two key parameters that will dictate how well a pump performs in your system. Flow rate is essentially how much liquid, whether it's water, chemicals, or something else entirely, you need to move per minute or hour. It's a measure of volume over time, and it's critical for ensuring your system gets the fluid it requires. Head, on the other hand, is the total height and resistance the pump must overcome to effectively move the fluid. This includes both the vertical distance the fluid needs to be lifted, as well as any friction within the pipes. Calculate flow rate based on your application. How much water do crops need, for example, if you're designing an irrigation system? Or consider how much chemical does a process require in an industrial setting. Head combines vertical lift, which is straightforward, and friction losses, which can be a bit more complex. These friction losses occur in pipes and fittings, and they depend on factors like pipe diameter, material, and the fluid's viscosity. Add up the vertical distance and friction losses carefully. Accurate calculations here are key. This sum gives you the total dynamic head, often abbreviated as TDH. These two numbers, flow rate and head, define your pump's duty point. This is the specific flow rate and head at which your pump needs to operate. Get them right, and you're set for the next step. A pump that's correctly sized will operate efficiently and reliably. Accurate numbers mean a perfect match between your system's requirements and the pump's capabilities. Let's move on to choosing the right pump type, now that we understand the importance of flow rate and head. Onward. Now let's pick the pump. There are two main families: centrifugal and positive displacement. Centrifugal pumps use a spinning impeller, great for thin liquids and high flow rates. They're reliable, cost-effective, and perfect for water and similar fluids. Positive displacement pumps trap and push fixed amounts of fluid, ideal for thick, sticky, or precise dosing jobs. Gear, lobe, and diaphragm pumps handle oils, slurries, and delicate solids. Choose centrifugal for lots of water, positive displacement for thick or precise flows. Matching pump type to your fluid and needs is where science meets engineering. The right pump makes all the difference. Let's talk materials next. Stay tuned. Pump type chosen. Now what's it made of? Materials must resist corrosion, abrasion, and temperature extremes. For clean water, cast iron or bronze works well. For acids, use stainless steel, special alloys, or plastic linings. Abrasive fluids need hardened metals or rubber linings to protect against wear. Don't forget seals. They must match the fluid's chemistry and temperature. The right materials mean longer life and safer operation. A failed pump or seal can cause spills and hazards. Material choice is safety and science combined. Let's power up. It's time to power your pump. But not just any power will do. We need to think about efficiency and making sure we're not wasting energy. To get the most out of your pumping system, choose the right motor and always think efficiency. Consider energy-efficient models that can significantly reduce your operating costs over time. It's crucial to match the motor to your site's power supply. Compatibility is key for optimal performance and to prevent any electrical issues. Voltage and phase matter significantly. Ensure the motor's specifications align with your power grid to avoid damage and ensure efficient operation. Pump efficiency is absolutely key to minimizing energy consumption and maximizing performance. A more efficient pump will save you money in the long run. Therefore, select a pump that operates as close as possible to its best efficiency point, or BEP. This ensures optimal performance and reduces energy waste. Don't oversize your pump. It might seem like more power is better, but that's not always the case. Remember, bigger isn't always better when it comes to pumps. An oversized pump can lead to a host of problems. In fact, an oversized pump wastes energy by operating inefficiently, costing you more money on your electricity bill. What's more, an oversized pump wears out faster due to the unnecessary strain on its components. That's where the Goldilocks rule comes in. It's all about finding the perfect balance. You want a pump that's not too big and definitely not too small. You want one that's just right for your specific needs. Consider the energy costs over time. These can really add up and impact your bottom line. In many cases, the energy costs over the lifespan of a pump can far exceed the initial purchase price. Therefore, efficient and properly sized pumps are a smart investment for long-term savings. They save you money on energy bills, and because they're operating within their optimal range, they last longer. So, do the math and calculate your potential savings. Don't forget to check the pump performance curves to understand how the pump will operate under different conditions. Take your time and pick the perfect fit for your application. It's worth the effort. Making smart choices about pump selection pays off for years to come in terms of efficiency and reliability. We're almost done. But before we wrap up, let's quickly talk about the importance of regular maintenance. With these considerations in mind, you're one final step ahead towards a successful and efficient pump installation. Think beyond the purchase. Maintenance matters. Easy access to parts and service reduces downtime and costs. Choose reputable brands with good support and spare parts availability. Consider total cost of ownership, purchase and installation, energy and maintenance and downtime. Cheap, unreliable pumps cost more in the long run. Use online selection tools to compare options and find the best fit. Follow these steps and you'll have a reliable, efficient pump for any job. Science leads to smart solutions.